see what the
number one
behaviors
is
they do.
that always. Excellent. So please plug it in. And tell me what you have at the top and what you have in the denominator. Anyone?
Zero over zero.
Yay! You like it? I do too. And very soon I will show you something very simple with this, 0 over 0. But I can't do it right now. Okay, so then what does that mean? Guaranteed what?
There's hope.
Good. And what?
X minus 4 is going to cancel out.
Absolutely. So then I'm only waiting for another factor at the top. Because 0 over 0, I have to have this. If I don't get 0 over 0, I cannot copy this out of the blue.
X, nope, never mind.
Yeah, x has to be x.
Plus 1.
Plus 1. Awesome. Okay. What is my next step then? So please remember, step number 1 is plug it in. Yes, I think Ryan said that, and he's right. In certain situations, I will have to start with a domain. He's correct. Maybe even with a rational function. But when I have 0 over 0, I still know it's not in the domain, but there is hope. Not guaranteed. It can still be undefined. It can still be DNE or infinity. It still can be, but there is hope. Okay. But the first thing, plug it in. Good. So what do we get? What is this limit? And this is the limit operator is there. The limit operator is there. Now I'm applying it because my next step is?
You would plug in you eliminate those two, but then you put the 4 in for X, and that makes that 5.
Ah. So if this is 5, thank you, and this is 5, and this is 5, what do I conclude about this?
It's continuous at a point.
Yes, it continues not at a point, but exactly at which point? When x is?
4.
Yes. Yes. Continuous at 4. Okay? So please be very careful. The definition should fit in one line. Of course, the way I write, it cannot ever fit in one line. But it should fit in one line, and the analysis for this limit should be underneath it. So this is the limit of this, which is very clear. It's a polynomial. It's 5. Here, I'm just plugging in 4, 5. And this needed calculation, so we did it on the side. The first step must be plugging it in. Okay, enough of that. Any questions for me, please? Any questions?
Sorry, I don't get one thing.
Yes, please.
About the last one. I get that's a continuity and all, but wouldn't it be a remove? Was it a remove?
Removable discontinuity will not equal at f of 4, but they're all equal.
I just figured because it says x is less than 4 and x is greater than 4, so neither of them equal.
Yes, it equals. It equals. Unless I copied
my
it.
bad. I didn't see that.
No, unless I copied it incorrectly. You know what? Let me look again. So it is. Okay. So sometimes I may copy no. Please always tell me, because you may see something and I don't. So I always designate somebody to make sure that I copy problems correctly in each class. So it is possible that and also remember, my device is so far away from me. So yep, very good. Good point. Yes. So you are absolutely correct. If we would have had x less than 4 and x greater than 4, of course, it's not possible. F is not, in this situation, F is not continuous at x equals 4. Absolutely. And if the limits are the same, it's removable. If they're not the same, it's not even that. Okay, so 1.2 for Wednesday, please. With 60% for my lab math and the homework that I will assign. So I'd like to continue with 1.3. I did talk to 2 of my colleagues to ask them where they are, and they finished 1.4. So as I mentioned, I am a week behind. So, however, in 1.3, we already talked about the difference quotient. So that makes me not be so far behind as I thought. So average rate of change and difference quotient. Okay, so this we know, and we can practice if we need to. But what is the average rate of change? We already discussed the average rate of change is what the difference quotient is based on. Okay, what is it? Okay, here's a function f of x, and I have 2 points. I have here point 1, I have here point 2. If you want to call them P and Q, same thing. And I want to define or determine the average rate of change of f of x between 1 and 2, or P and Q. How do I determine that? So that the whole thing will equal, of course, y2 f of x2 minus f of x1 over x2 minus x1. What is it? It's the slope of this line, where this is y2, this is y1, this is x1, and this is x2. Nothing new, really nothing. So let's take a look at a couple of examples and determine that. Okay, so page 133, where is my keyboard? 133. Now let's take a look. Okay, so let's choose something. We can start with a problem like this. I know I'm down to a few minutes. I know that. Please don't let me 2 minutes. Okay. Okay, so let's look at problem, let's say 17, and then we'll stop after this. You're not responsible for 1.3 because I didn't finish it. So f of x, so this is 134, x squared plus 2x, x1 equals 0, and x2 equals 6. Okay? So I'm asked to find the average rate of change. Immediately, I have to find f of x1, and I have to find...
Lee?
Say it again?
Miss Lee, I'm having issues trying to upload the notes right now.
But you have to upload the notes, not all the notes, just when I say so.
Yeah, but I saved as a PDF, but it's not letting me download it.
Oh, okay. I forgot.
I'm still trying.
That's okay. You can email it to me.
All right.
Okay, so can anyone give us f of 0?
0.
Very good. Can anyone give us f of 6?
48.
Yes, because it's 36 plus 12. Very good. 48. And finally, can anyone dictate the average rate of change? And I'll stop. Average rate between 0 and 6. 48 minus 0 divided by 6 minus 0.
8.
Very good. Please remember, in this case, we don't have measurement units, but this otherwise should have 2 measurement units. 2 measurement units. One coming from the top over one coming from the denominator. 2 measurement units. One for this, which is the y value, and one for x, which is the x value. Thank you.